And this is the topology we'll be working with in the sandbox. This is totally free and reservable on DevNet as well for anybody else. We have a couple iOS devices. We have Internet Router 1, Distribution Router 1 and 2, Edge Switch 1 are all iOS devices. We have 2 XR devices with Core Router 1 and 2, and then 1 ASA device. There are Nexus devices in this topology, but because of a CML bug we're working with right now, we're not going to be touching the Nexus today. And we're not going to be doing anything too fancy on the networking side, so no need to memorize all the subnets and OSPF heroes and all that kind of thing. So we are on a Linux terminal right here for a jump host that has NSO installed on it. And so to enter the NSO CLI, I'd use NCS CLI, because that's the old name of the product before they were acquired, and log in. And you'll see hopefully a familiar, more or less familiar prompt with the hashtag or # for us older folk. And I've already added the devices in here to save some time. I've added in device groups, but basically the way NSO works for that, it just has a series of commands. You enter in the IP address, port number, device type, and then you can actually store the credentials in an AES encrypted string in the CDB, and it's decrypted at runtime behind the scenes. So that's another thing for network automation. I know people getting started, it's like, how are we going to store credentials securely? Are we going to use Vault or something else? Well, NSO does that for you. So once you typed in and saved it, you don't have to worry about that from a security perspective. So you can do different show commands. So if I do a show devices list, that will show us the list of devices we have connected here. We have, like I said, 2 XR devices, 1 ASA device, and a handful of iOS devices. It gives us our IP addresses as well. And if I can see the devices we have in our device group. Remember. So we have a device group with all our devices that I've added in. We have a device group for our 1 ASA device, our iOS devices, and our XR devices. And these little brackets are just indicating these are the things I have in that particular group. And if I want to connect to my devices, NSO doesn't maintain a persistent connection with all its devices. It's not like the Eye of Sauron, always seeing everything that goes on all the time. It only talks to the devices when we're asking it to do something with NSO. And so if I say devices connect, it's going to, I can scroll up and go through all the devices. In this case, we're connecting over Telnet port 23. And it's telling us result true in the sense that we have established connectivity to the devices. But at this point, I haven't actually had NSO learn the configuration yet. And I can actually verify that by doing a show running config. In this case, I'm saying show running config against the CDB, the NSO. So even though we're used to seeing show running config on a per device basis, we're using that same naming convention within NSO to talk about how we're interacting with the NSO application. So I'm going to say show running config. From all my devices, I want to look at one device. And we're going to look at Internet Router 1. And look at that what does NSO understand that device is configured to be. At this point, it just has some placeholder basically telling me I don't know the configuration yet.
And Jason, this is Tony. It's getting the configuration from the device, or this is what NSO has stored locally that says this is what I think the device's configuration is?
This is pretty much what you see for any device that has no configuration NSO. So even though you see lines here, this is basically telling me that it doesn't know any configuration yet. So it just placeholder configurations for any new device.
Oh, is it retrieving from the device, Tony says, and I was wondering that too.
We'll retrieve from the device in the next step. So if I go devices sync from, and with that one command, we're doing a lot of things behind the scenes. So we're logging into all the devices in our device list. We're doing a show running config, show version, then parsing that all into the local CDB. So now we'll have our updated copy reflecting what is actually on the device for all the devices. Does that answer your question? Okay.
I think so. So with that sync command that you just ran,
yeah,
it's then retrieving the configuration from the devices. Okay, I understand. Thanks.
Yes.
And not yet. It seems not yet.
And I'll cancel out that command, but we can say I can push up arrow, show run config, same exact command. And if I have enter, now we have, it gives us the version, so with that information. But if I space bar down, we can see we have a static route, crypto certs, interface gig 1 through 4, some BTY lines. So it has that across all the devices. So it's learned that configuration, and I can actually go into the log file. I have this pulled up. This is a trace file. Is not typically what a normal user would look through, but since we're showing kind of behind the scenes what is going on, we can say username. We can see in our log file that NSO in the whatever 2 seconds that we saw it sync from. This is what was going on behind the scenes. It connected to our device. It got to the telnet prompt of username. It plugged in the username of Cisco, and then had the password prompt in telnet. And the log file doesn't show us the password, but it was able to get into the device and then do a term length 0, term width 0, show version, and then go on its merry way to, I think, also show running config, show boot, and a bunch of other commands. So all of this was going on behind the scenes when we said sync from, and did that for every single device.
If I can just chime in with one piece of context too, with the questions that were coming from Tony and the rest, a key piece to recognize here that is different about NSO from some the other automation tools is once NSO has done that sync from and learned the configuration for the devices, it now has, like, in its CDB, its database, what the device configuration is supposed to be. And so that allows NSO to do a lot of what if analysis, limited config changes as you move forward. And it also allows at any point in time to make sure that the network configuration is what it's supposed to be, if we assume NSO is what it's supposed to be. And so I like to say it's a great way to prevent kind of cowboy engineering, somebody going out of band from like the proper framework and tools to go through, because at any point in time, NSO can kind of do that check to make sure, is the network what it's supposed to be?
And just to that point, while you're talking, I multitasked and exited out of the NSO application back to the Linux terminal, issued a telnet command to Internet Router 1. And so we're doing out-of-band change outside of the NSO's knowledge. So I'm the cowboy engineer. I log in. Let's say I add in into loopback of 100. We'll add a description of out-of-band change for Cisco defined. Exit out of that. Go back in NSO. So I had outside of NSO's knowledge, because NSO only talks to devices when we're trying to do something with the device. So outside of NSO's knowledge, I went into Linux, telnetted to the device, added some configuration change, and now if I do a devices check sync, it will do a hash basically against what the local copy and what the actual device is, and it shows all my devices are in sync except for that Internet Router 1. It shows I was expecting this particular hash, I got a different one, so there was something different between those two, what my last known good copy and what's actually on the device. And so there are different ways you can handle that. You can do, instead of doing a sync from and updating my NSO copy, I could also do a sync to and wipe out what is the change of someone else that shouldn't have been done possibly. Or I could do a sync from and update my local copy if I think that change was a good one. So if I want to see what that change was from an NSO perspective, I can say devices, sync from, try run. And the dry run is telling me I'm not actually going to update my copy yet. I just want to know what the change would be. And so it tells us, and this is the kind of behind the scenes, NSO likes to use what we call the J-style CLI, for those of you who understand what J-style CLI would be. And even though we're working with iOS config, we have it rendered here in J-style CLI. So we have this Internet Router 1, since we last talked to it, somebody added a loopback 100 with this description. And it's telling me if I'm actually going to run this sync from, it's going to update my NSO copy to add that out-of-band change. So it automatically detects what the exact changes were, and it's going to update the local copy. Or I could say devices sync to, and it would remove that change. So it just depends on when you see the change, what do you want to happen? Do you want the out-of-band change? Was that a valid change? Wipe it out. I mean, keep it, or if there's invalid change, wipe it out. So it allows you to treat NSO truly as that single source of truth, and it's able to update dynamically based on what is going on in your network.
I'm just wondering, is there any sort of correlation between sort of what the current network design is and the change that was made. What I mean is what if the cowboy engineer introduced a loopback and a BGP neighbor that was sourced from that loopback? Then you went back into NSO and you did the resync, and it noticed, hey, there's a loopback here and a BGP neighbor, and you say, oh, well, we can't have these extra loopbacks, so we should be removing that. In turn, that's also going to take down the BGP peer. Is it going to sort of know about that waterfall effect, that if I remove one thing, it's going to affect another?
Yeah, so I'd say that's where the model-driven part is a lot more important than just being text files like when we were talking about YAML and Jinja, is that it understands the relationships between the config. So if you have an ACL applied to an interface, or in your example BGP, it's going to see that it's going to be removing multiple pieces at once and notify you of that. So you have, when you have those dependencies in place, it's going to show you, here's all. It's not going to tell you operationally how it's going to change the network, but at least from a configuration standpoint, if you have configuration that is tied to another piece of configuration, it will let you know that that's going to be a problem.
Nice question, by the way. But for the BGP, even a new loopback wouldn't bring the peering down, because you need to manually set all the peerings anyway, even in the dynamic peer templates.
Yeah. And like I said, same thing for ACLs. If you're trying to remove something that's linked to another piece of configuration, NSO will tell you this is connected to another piece of configuration. Are you sure you want to do that?
So was that out-of-band change even applied, or was a change only applied within NSO when you specified to sync it or leave it as is?
In this case, it's still out of sync, because I just did 2 dry runs. I had the sync from dry run and the sync to dry run. So I haven't actually changed the NSO's copy to be in sync. So in this case, I'll just say devices sync to and wipe out that change. And
okay, so the out-of-band change was actually applied.
Yeah, that out-of-band change, it noticed it was changed. It said, oh, there's a difference between what I know the config to be and what's actually on the device. What do you want to do? Do you want to wipe it out, or do you want to keep it? In this case, I decided to wipe it out.
Okay.
Okay. Now, I'll show you for your configuration, because we're dealing with more than just a text file snapshot, we can actually look at all of our configuration in JSON and XML. I know for network engineers, this might not be the most exciting thing to see, but for the people who have started going down their automation journey, seeing configuration for legacy iOS devices or any device across the board, having that configuration rendered in a programmatic format is super interesting, let's see, because it allows you to then programmatically interact with whatever piece of configuration you want to work with. So what we're working with here is just a legacy iOS device. It's not running netconf, restconf, anything above the board. Those nets, those device abstractions, are parsing all the configuration for us, so we can treat any device basically as a programmable device and manipulate the configuration on a granular level. So I was looking at here, I said, show running config, show me my snapshot of this device's interface configuration, show it in the JSON format. And because behind the scenes, it's parsed all the configuration for me, it says, okay, here's all the interfaces in JSON. So we have gigabit Ethernet 1, gigabit Ethernet 2. And I mean, this is not something that humans want to be typing out or reading, but it just kind of shows you behind the scenes, it's not just a text file. It's literally, it can transform it between JSON and XML or the native CLI. So we have the same interface configuration for this iOS device, and it's being rendered in XML format. And I found that to be especially useful because sometimes there are devices on your network that are never going to be upgraded, or they're going to be there for so long, you're never getting an API to that sucker. And like what this allows you to do is to have that level of complexity and programmability done on the server side. And so from the device's perspective, all it sees is commands being sent to it from NSO, but NSO on the backside has all the devices in this XML JSON format. So then you can do all kinds of fancy programmatic things. Because NSO is able to swap between XML, JSON, and CLI, kind of back and forth between the three.
Okay, so question. So I played with Postman for ACI.
Sure.
Like if I was trying to sell someone on the advantages of NSO over playing with something like Postman,
Sure.
Besides the ability to sync, what are the other advantages?
I'd say also rollback and also services. So what I'm showing here are more of the basic features. When we get to Hank, we'll show some of the kind of the more pizzazzy stuff. So I'd say overall, like the key differentiators for me when I was a network engineer were I get to start in a Cisco CLI. I get to have all my devices be programmable no matter where they are. I have a snapshot on the configuration to play with. Like Hank was talking about, you can do a commit, dry run, and see what the commands would be. You can then roll back any change that you're working with. And so when you're making your change, if you at the end of it see operationally it's making the problem your network, as long as you still have connectivity, NSO can then calculate whatever changes you made, it will calculate the reversion of that. And then in terms of more advanced features, being able to have NSO programmatically connect to other applications, and then also have services where you can bundle up your configuration into more, I'd say, bite-sized chunks, which Hank will show in a little bit, but I'd say that's usually more out of scope from what I expect network engineers to get started. I'd say for getting started, having a local copy to play with, and then having those rollbacks would be the main things.
Okay, thank you.
I think also the way changes are made, there's some nuances and subtleties that NSO treats the network as a database, so all the transactions are fully ACID compliant. That works on a two-phase commit type of process. So if you're having complex changes, either the whole thing is applied or not, which protects you from partial failures. And if it, as Jason said, if it's a rollback, it's a full rollback.
Yeah.
The other thing I think that's kind of cool is we have technology called FastMap, which because NSO has a complete config and you push a change through, it figures out the least amount of work it needs to do to get the device to the desired state. So if you look at something like ACLs, right? If I change an ACL block, it doesn't wipe out the entire ACL stanza, then rebuild it in, which creates a security hole in that transition. It'll just figure out, okay, this is a specific line, or these are the specific characters, and it applies patches and rollbacks very atomically, which provides minimizes the amount of churn that's happening on the device as we implement changes and roll things up or roll things back.
Yeah,
you said something interesting in there about phased commit.
Yeah.
How is that being accomplished on devices that don't have phase commit natively, right? So iOS XE are not traditionally phase commit.
Yeah.
Type
So
type structures.
I'll show you for an iOS device right here. So let's say we have a device going back to Internet Router 1. Okay. We can add in, let's say, an interface. And if I do a question mark, it actually, since it knows the configuration, it'll show me the descriptions, show me the available interfaces. And I'm not actually making any changes on the devices yet. I'm just changing the NSO's local CDB copy. So that's the first phase of the commit, where I'm making a pending change onto the NSO's copy of the configuration. And if I add, say, a description, let's see, new loopback or new change. I can update the IP address. And if I do a question mark, it'll show me actually what the IP address was based on what it learned from the device. We'll say 162.61.0.1. And it has the same thing for the subnet mask where it's learned that from the device. And so right now I've made these changes to this iOS device, and it actually hasn't talked to the device at all. The device might be down for all NSO nodes. And I've had that problem before too, where you need to wait for the device to come back up and have those types of things. But when we've made this pending change, we can say commit dry run. And that will show us, I'm going to be removing this old description. I'm going to be adding this new description. And I'm going to be removing this IP address. I'm going to be adding this IP address. And this is in the JStyle CLI. I can also say at format native to say, show me what the commands would be from an iOS perspective. I'm going to be sending a new description, and I'm going to be saying this following IP address. So at this point, I've done the commit dry run. I haven't actually committed it, but when I issue the commit change, then it'll log into the device and issue the commands. So from the device's perspective, the device doesn't know that it's a two-phase commit. All it knows is that commands are coming in. But from the NSO perspective, you're able to do those manipulations, and then when you're finally ready to commit, then it sends the commands.
Okay, that's cool. So I guess then my next question is, how do we make sure because I mean, a lot of the purpose of the phase commit is the idea that, order of operations matters. When you talk about a non-phase commit device, I go and change an IP address, I lose connectivity. Maybe I need to change the ACL first, right? Is that all planned out in how NSO approaches individual line configs? I mean, you guys have some context around what order operation should be to make sure you don't lose connectivity. What does rollback look like? I mean, how does that get handled?
Yeah, so I would say if we kill connectivity to the device by changing the management IP or something, that's kind of on you as the engineer. So NSO needs to be able to have connectivity, but I would say if you're doing other things that have sequence of events, like you need to have this interface be present before you have the ACL applied to it and things like that. And NSO has those NEDs, those network element drivers for each of the device types. I'd say tens of thousands of lines of code behind the scenes that are doing more than just doing show run. They're executing, they basically programmed in those sequence of events for all the commands that are supported for those devices. So yeah, I'd say for anything else apart from killing your own management interface, it has all those sequences ordered from you, and then also the reverse sequences ordered for you when you want to roll back.
All right,
just as you reload in 5 before every change.
Yeah.
Is it just me?
Yeah.
Still use it, man. It's still
Absolutely.
out there.
Yeah, safety.
So if I issue commit here, and I can pull up my handy dandy log file, so it took about 2 seconds. We can look for my Chang, misspelled. Chang. Let's see, interface. We'll look for the IP address. So we can see behind the scenes in this fancy dancy log file, this is the configuration change I'm going to send, and basically that's what it's sending behind the scenes. I think comp. And I can show you the rollback from this change. So if I go to, I'm still in the config mode. If I say show configuration rollback changes. So if I want to roll back to my previous commit, it says I would need to go back to this previous interface description from my new chain and then go back to the old IP address. So I just issued one command and said, what's the last configuration change I made? And then it says, if you want to roll that back, these are the commands we would do to get back to that state. And if you want to see all of the commits, you can go into rollback configuration, do a question mark, just like any iOS device. And these are all the commits I've done from the NSO application here, and then also before we started. So if I wanted to roll back to a previous state, I could select one of those states and then roll back to that state. So in this case, I have this, basically, whenever I make a change, not just across one device, but across many devices, like Omar was saying, if you run into any issue and then let's say a command doesn't take or something fails, it automatically issues the rollback across all the devices. Okay, let's see. Do one more demo before we hand off to Hank. Actually, 2 more demos. One showing templates, and then one showing NSO interacting on the show command side. So the way NSO works with templates is that it treats it kind of like a golden config, where we can tell NSO we want to have this configuration be present on our devices. And if it's not present, add it to it. If it is present, you don't do anything. There are other ways you can merge, replace, do more fancy manipulations, but for the sake of our purposes, we're just going to be merging in new config if it's not there. So I'm going to copy and paste in some configuration here just for the sake of not having to watch me type. So what we have here is I'm still in the NSO configuration. I'm configuring the application itself. So I'm not talking to any devices yet. I'm adding a new template. I'm calling set DNS server for 3 different device types. I have an iOS template, an ASA template, and an XR template. And the nice thing about working in the CLI is that you could just enter the commands, issue question marks, to see what the next commands are, do command completion, just like a network engineer would, but you're actually creating a template in the process. And so we have a DNS server of .222, .220 for iOS, ASA, and XR. So we have 3 different device types represented. in this template. So as we apply this template to our device list, NSO will automatically basically filter out. It knows this is an iOS device, so I'm going to apply the iOS template. I know this is an XR device. I'm going to apply the XR part of this template. So you're not going to have to worry about having to apply it to the specific ones. You just apply it to your devices generally. And I want to commit. So basically, I want to save those templates into my NSO application. And now we can go back to, we have those device groups. So I have my all group. So I can apply this template to all my devices. I can do a question mark, and it will show me my possible completions based on what it knows my templates to be within my NSO application. In this case, we just have one we just created called set DNS server. And so now we've applied this template to all of our devices in the CDB. We haven't actually sent any commands to the devices. We're just interacting between what we have in what we want the config to be and what we know the config to be versus NSO snapshot. So we have core router 1 and 2, distribution router 1 and 2, our firewall, and internet router 1. We've applied the template, and we can see what commands it would send if we do a commit dry run out format native, telling us what native commands we want to send. So that template is now applied to all of our devices. So we have our DNS servers 222, 220 across iOS devices, our ASA device, and then our XR devices. And if we want that to actually be sent to the device, instead of just saying commit dry run, we would then say commit, and it would send to our devices. Any questions about what's going on there so far? Okay. If we want to roll back the configuration, we could say roll back configuration. And it'll calculate what does it need to remove from the last change we made. We can see what that change would be, saying show configuration. So it'd say for each device, I'd just issue a no domain name server for that configuration.
On that rollback configuration command, what's interesting is that it assumes you mean the last configuration, but every configuration change that's ever been made is stored. So you could roll back a change from the previous day or 4 changes ago. And that's that value of the CDB is NSO will look at it and say, if you want to roll back this change first, is it possible based on all of the other things that may have happened since then? And if so, this is what it would take to roll just that change back. Depending on what's happened since then, you may get into a case where you couldn't roll back one transaction without other transactions.
Okay, so it's not rolling back to the state 4 changes ago. It's actually saying, you're actually saying, I want to roll back that specific commit.
Correct.
Okay, which is that's quite different to a lot of other commit-based mechanisms.
Yeah.
That's interesting.
Yeah. And then now I'll show a few operational show command, because you can do that with NSO as well. NSO is primarily a configuration management tool, but you can still send commands directly to the devices as well. So it stores, when it does the initial sync from, the information of platform name, what OS version we're working with, platform model, serial number. So if we do show device, internet router 1 platform, we have that information. And if we want to just drill down into serial number, we could ask for that as well. Now, what's more interesting is that we can say show devices, device, and then use wildcard star platform for all our devices. And then it will show us, we have all our devices, all the device types, what OS version they're working with, what model, and what serial number. And in this case, the XR device's serial number actually is NA. I had to log into the device and see that happen. Oh, is that a bug? Which is pretty helpful if you just want to get a snapshot of, are we PCERT compliant? Do we have any issues on our network in terms of what OS version we're working with, serial numbers, information like that.
Is there any way to group these? I mean, this is great when you have 5 or 6 devices with a star, but I can imagine when you're running hundreds of devices, you're gonna have some sort of logical groupings you'd like to be able to pull stuff like this for.
Yeah, so it has the device group mechanism that we'd used before, and then you can also, for any command, do pipe save, and then save it to a text file. And so I'd say that's another common mechanism is if the terminal's too much information, you want to save that to an external file for any command you're working with. And we can do devices. If we want to actually send any specific command to a device, we can use what's called the live status command, where we say exec, and then whatever command we want. We'll say show IPN brief. So previously what we were working with up here was from when it did the sync from, it captured that information for us and saved into the CDB, but now we can actually talk to the device with whatever command we want. If we want to do a show IPN brief on this particular device, we can say, exec live status show IPN brief, and gives us that information. We could save that to a file. You could also do that, with, let's delete this, multiple devices. So we can say dist router star live status exec any show IP route. And it has the show IP route information for us. And for that, I was basically just using the star as the wildcard for us to send the same command to both router 1 and router 2. And I'd say for more complex sending show commands, that's where I typically go to Python, because trying to do that with 50 devices or 100 devices, is a little unwieldy. And the Python API, it mirrors what we're seeing here on the command line. And so you could just say like for device and device list, send show IPN brief, save that to a file, or put it through if text FSM. You can use a text FSM template to then parse that into JSON or XML. Because NSO is only parsing the configuration data here. And that ends it from my perspective. So any other questions in terms of what we have for the demo before we go on to Hank? Great. Feel free to reach out to me as well on Twitter and LinkedIn.
So one thing I'll just want to build upon something that Jason mentioned on the NED. So there is a lot of logic that's built into the NEDs. They're not just keyword translators. So like someone asked about ordered sequence. So the logic to actually order commands in the proper sequence are there. One of the more useful things is actually going the other direction is normalization of error messages and those kinds of things. So if you have, Juniper routers and Cisco routers and whatever, you can get normalized error messages going back the other way. So your service logic does it. So you don't have to build those things into your service logic. Your service logic can be fairly clean and straightforward. And then all the device stuff, device specific stuff gets handled somewhat transparently at the NED.
And I'd say on top of that, I know a pain point for people who work in multi-vendor networks or even multi-platform networks is even if you do have APIs into your devices, they have different ways of handling credentials, different paths to get to the same resource, and you're having to normalize across all those different device types, even if you have devices that have APIs. And since NSO kind of normalizes that all within its own ecosystem, it allows you to have kind of a simplified, unified interface for devices that don't have APIs and that do have APIs, but might have APIs that are inconsistent across each other.